Somewhere in the South Atlantic Ocean, on April 6, 2026, a man woke up with a headache and a mild fever. He was on a luxury expedition cruise ship. A dream trip, Antarctica, South Georgia, remote island chains few people ever see in their lifetime. By April 11th, 5 days later, he was dead. And the virus that killed him? It wasn't supposed to be able to spread from person to person. This is the story of the MV Hondius outbreak, the Andes Hantavirus, and why what's happening right now could change how the world thinks about the next pandemic. Most people have never heard of Hantavirus, and that's exactly the problem. Hantavirus is a family of viruses, nearly 40 known strains found on every inhabited continent. They live in small rodents, rats, mice, the pygmy rice rat in South America, the deer mouse in North America. Normally, humans get infected one way: contact with an infected rodent's urine, droppings, or saliva, often through particles that become airborne when you disturb an old nest or sweep through an abandoned building. The disease it causes, Hantavirus pulmonary syndrome, or HPS, attacks the lungs with terrifying speed. Fever, muscle aches. Then, within days, the lungs begin to fill with fluid. Respiratory distress, shock. The case fatality rate for severe HPS? Approximately 40%. Not 40. There is no approved antiviral treatment, no vaccine. Doctors can only offer supportive care and hope the immune system fights back in time. For decades, Hantavirus was terrifying, but manageable, because it had one crucial limitation: it couldn't jump from human to human. That was the firewall. That was what kept it from ever becoming a global threat, until the Andes virus. On April 1, 2026, the MV Hondius, a Dutch-flagged expedition ship, departed Ushuaia, Argentina, with 147 people on board, 88 passengers, 59 crew, 23 nationalities. A remarkable voyage through some of the most remote places on Earth. What no one knew was that somewhere in the embarkation process, possibly in the wildlife-rich regions around Ushuaia, someone had already been exposed to the Andes strain of Hantavirus. April 6th, Case 1 develops fever, headache, mild diarrhea. By April 11th, he is dead on board. No microbiological tests are performed. The ship sails on. April 24th, a woman, a close contact of Case 1, goes ashore at St. Helena with gastrointestinal symptoms. She boards a flight to Johannesburg. She deteriorates mid-air. She dies in the emergency department upon arrival on April 26th. Later confirmed, Hantavirus. April 24th, a third passenger presents to the ship's doctor. Fever, shortness of breath, signs of pneumonia. 2 days later, medically evacuated to South Africa. PCR confirmed, Hantavirus. He remains in the ICU. April 28th, a fourth passenger develops fever and begins to deteriorate. She dies on May 2nd. By May 4th, just 28 days after that first fever, 7 cases, 3 dead, 1 critically ill. The ship moored off the coast of Cabo Verde, passengers confined to their cabins. The WHO activated. And here's where this gets truly alarming. Before authorities identified Hantavirus, before anyone realized what was happening, roughly 40 passengers had already disembarked and returned home, across 23 countries, on multiple commercial flights, potentially incubating a virus that takes up to 6 weeks to show symptoms. The WHO called it a cluster of international public health concern. Here is what makes the Andes virus unlike any other hantavirus on Earth. It is the only strain with documented human-to-human transmission. Every other hantavirus, the sin nombre virus, the Sol virus, the Pumala virus, they all dead-end in humans. They cannot efficiently jump from person to person. That is the single biological fact that has prevented a hantavirus pandemic for decades. The Andes virus broke that rule. Scientists aren't entirely sure how. It appears to spread through respiratory droplets, coughing, sneezing, close contact, and through bodily fluids. Not truly airborne like measles or COVID. But close enough in a confined cabin, close enough between a couple sharing a bed, close enough that one person attending a birthday party in Argentina in 2018 triggered what became a documented superspreader event, confirmed in the New England Journal of Medicine. Person-to-person transmission accounts for only 2 to 5% of all Andes cases. That sounds reassuring until you do the math on a ship with 147 people. Until you consider the 40 passengers who flew home before diagnosis. Until you understand that one infected person at a crowded birthday party once ignited an entire outbreak chain. The good news, and there is good news, is that the Andes virus is not COVID, not even close in transmissibility. One infected person typically infects fewer than one other person on average. The WHO currently assesses the global public risk as low. But the science has a warning buried beneath those reassuring words. The conditions that made this outbreak possible, those conditions are multiplying. Now, here's where medicine meets the future. This outbreak exposed something that public health officials have known for years but rarely say out loud. Our early warning systems failed. Days passed between the first death and the first alarm. Weeks passed before anyone connected the dots. By the time Hantavirus was even on the diagnostic list, multiple cases had already occurred. A woman had died mid-flight, and passengers had scattered across the globe. This is not a criticism of the doctors and nurses on that ship. They were dealing with an extremely rare disease, one that mimics common respiratory infections in its early stages. This is a systems problem, and artificial intelligence may be the solution we're not deploying fast enough. AI-powered outbreak surveillance systems, like the ones already being developed by WHO, the CDC, and private companies, work by scanning millions of data signals simultaneously. Hospital admission patterns, pharmacy purchase anomalies, social media symptom reports, airline route data, rodent population shifts driven by climate change. A well-trained AI system could have flagged the unusual cluster of severe respiratory illness on that cruise ship in its second or third case, days before any human epidemiologist connected the pattern. And climate change is making this more urgent. As global temperatures rise, the geographic range of the rodents that carry hantavirus is expanding northward. New habitats, new human contact zones. A virus that was once largely confined to rural South America is slowly finding new frontiers. AI-based rodent population surveillance, cross-referenced with climate migration models, already exists in prototype. The question isn't whether the technology can help. It's whether we'll build the political will to fund it before the next outbreak catches us off guard. If this story matters to you, and I think it should, hit subscribe right now. MedPulse exists to explain exactly these moments. When science breaks through to the surface and the world doesn't quite know what to make of it yet. Hit the bell. You'll want to be first when we cover what happens next. Let's be clear. The scientists are not panicking, and neither should you. But let's talk about what a world that ignores this warning looks like. The Andes virus currently has no approved antiviral treatment. No vaccine in late-stage trials. If, and this is hypothetical, the virus were to acquire mutations that enhanced its human-to-human transmissibility even modestly, the global health community would be facing a pathogen with a 40% fatality rate and no medical countermeasure. Compare that to COVID-19, which had a case fatality rate closer to 1 to 2% globally, and brought the world to its knees for 3 years. The 2018 Epuyén outbreak in Argentina, the birthday party superspreader event, involved only 34 cases. It was contained. But it happened in a small, rural Argentine town, not on an international expedition cruise ship carrying 23 nationalities, with passengers dispersing globally before the diagnosis was even made. Geography used to be our best defense against emerging viruses. In a world of 100,000 commercial flights per day, that defense has been eroding for decades. The MV Hondius outbreak is a stress test. And we only barely passed it because the Andes virus's transmissibility is still relatively low. The question scientists are quietly asking is, how many stress tests do we get before one of them is a different pathogen, with a higher R0, and we're not ready? So what does a world that takes this seriously actually look like? First, invest in AI-powered global disease surveillance, not as a pilot program, as core infrastructure. The technology to detect anomalous illness clusters in real time already exists. The will to fund it universally does not. Every week this remains underfunded is a week the next outbreak has a head start on us. Second, accelerate hantavirus research. There are currently no approved antivirals specifically targeting hantavirus. Monoclonal antibody therapies are in early research phases. mRNA vaccine technology, the same platform that produced COVID vaccines in record time, could theoretically be adapted for Andes virus, but only with funding, urgency, and scientific prioritization. Third, rethink travel medicine. When a ship departs from a region known to carry a lethal virus, with wildlife exposure on the itinerary, systematic pre-boarding screening and post-voyage symptom monitoring should be standard, not optional. Travel medicine is the weakest link in our outbreak response chain. Fourth, take climate-driven disease risk seriously. Hantavirus is a climate-sensitive pathogen. As temperatures rise, deer mice and rice rats expand their territory. This is not future speculation, it is documented. Climate adaptation policy and public health policy are the same policy. We cannot afford to treat them as separate conversations. And finally, perhaps most importantly, build a culture of diagnostic curiosity. The doctors on that cruise ship were not negligent. Hantavirus is rare, but a 40% fatal respiratory illness that doesn't respond to standard treatment protocols should trigger broader pathogen screening automatically. Every severe unexplained pneumonia case in a travel context should carry a reflex workup for emerging pathogens, not just the usual suspects. The tools exist. The knowledge is growing. The technology, especially AI, is reaching a capability threshold that our grandparents could only dream of. The only question is whether we use them before the next outbreak or after. The MV Hondius is moored. The passengers are home. The WHO continues to monitor. For now, this outbreak appears to be contained, but the virus hasn't changed. The climate hasn't reversed. The surveillance gaps haven't been closed. And somewhere in the tall grass of Argentina, a pygmy rice rat is carrying a pathogen that humanity has barely started to understand. Science is watching. Medicine is advancing. AI is learning. The question is whether we're listening before it matters. If this video gave you something to think about, share it. The more people understand emerging disease risk, the better prepared we are as a species. Subscribe to MedPulse for more stories like this one. And tell me in the comments, if AI can predict outbreaks before they happen, should governments be legally required to act on those predictions, or does that cross a line?